Hi and welcome back. So I'm doing another problem here. This one's going to be problem number 22 from the first signals recitation, and I have to go find a new spot on my digital paper. Okay, I think I found a good spot. So this is problem 22 out of 22 from the first signals recitation, and it's kind of combining what we've been doing over the past maybe 5 videos. So in this problem, what we have, we're given a function, x of t, which is equal to the cosine of 3t times the sine of 4t, and I want to represent this function as a sum of complex exponentials. So that's the problem. If you haven't tried one of these yet, this one's kind of challenging, but it's a really good one to start with, to try to do on your own. So if you want to pause the video, now's a great time. And now I'm just going to go through with doing the problem. So what we're going to use to do this is we're going to use the two kind of formulas that we built in problems 19, and then we built another one in problem 21, where we figured out that if we want to represent cosine, I'll write k cosine omega t plus phi, that we can represent that as k over 2 e to the j phi e to the j omega t plus k over 2 e to the minus j phi e to the minus j omega t. We figured this out. This was from video number 19, problem number 19 from the first recitation. And then we also figured out in just the last video that we did, and I made a little bit of a mistake when I was doing this, but I caught it at the very end, that if I have a sine wave, k sine some other omega t plus phi plus phase, that I can represent that as k over 2 e to the j phi minus pi over 2. And this also tells you a little bit something about how you turn a sine into a cosine. I would just have to subtract pi over 2 from the expression inside of the sine. So phi minus pi over 2 e to the j omega t, e to the j omega t, plus k over 2 e to the minus j phi minus pi over 2 e to the minus j omega t. That's what we figured out in the last video. We figured that out in problem number 21. So now what we're going to do in this video is we're going to take this function that we were given. This is our x of t. We're going to take this x of t, convert it into complex exponentials, and then multiply them together. And then that's how we're going to get our answer. So first off, the k's for both our cosine and our sine are both 1, right? And we don't have a phase shift for either our cosine or our sine. So let's first off, I'm going to do the cosine in this color, this bluish color. So our cosine, if I want to represent that in terms of complex exponentials, our k is 1, so I have 1/2. And actually, you know what? I'm even going to factor out the 1/2. Factor out the 1/2 times e to the j phase, so our phase is 0. So if I raise e to the j times 0, anything raised to the 0th power is just going to be 1, so our phase drops out, times e to the j omega t, our omega here is 3, so e to the j 3t, plus, again, 1/2, we've already factored out our 1/2. Again, our phase information just gives us 1, e to the minus j times 0, anything raised to the 0th power is 1, times e, so I add on, plus e to the minus j, 3t, and that's it. That's all we need for our cosine. This sum of complex exponentials represents that cosine part of the function. So now, after we have that, let me do a yellowish color for my sine function. So now for the sine, well, anyway, this is the cosine. Now for the sine, we're going to multiply this stuff times what we have for sine. So what we have is we again have k over 2. And again, our k is just 1, so we're going to have 1/2 1/2. We're going to factor that out of the expression. E to the j phi minus pi over 2. Our phi is 0, so we're just going to have minus pi over 2 here. E to the j, let's see, e to the j minus pi over 2 times e to the j omega t. The omega for our sine is 4, so e to the j 4t. And now I add on, I've already factored out my 1/2, plus e to the minus j, phi minus pi over 2. Phi is 0, so I just have minus pi over 2. E to the minus j times 4t. And now, pretty much I just multiply these two things together. And I get 1/4. So now I'm going to multiply those two together. So I get e to the j 3t e to the j minus pi over 2 e to the j 4t. That's my first term. Plus, so now I'm going to multiply, so first outside, so let's do the outside, e to the j 3t, e to the minus j minus 2 pi over 2 minus j minus pi over 2, e to the minus j 4t. So that's first, that's outside, that's in, the next one is going to be inside, plus e to the minus j 3t, e to the j minus pi over 2, e to the j 4t. And now the last one, I'm just going to write it down here. So I have first, outside, inside, last. So I'm going to have e minus j 3t, e minus j minus pi over 2, e minus j 4t. And so now that's pretty much it, and all I have to do is I have to simplify this number a little bit. And now remember, what I can do when I simplify this number, if I'm multiplying these exponentials together, I can just add the exponents, right? And like for this one, I've got, well, I'm going to leave my phase. This one kind of gives me my phase information here. I can leave that phase information sort of out front. But that j3t and j4t, I can add those together, right? I can get that this whole thing is going to equal 1/4 times e to the j minus pi over 2 times e to the 3 plus 4, that gives me e to the j 7t, right? And now I can do the same thing for this next part. I can say positive 3, I can just leave my phase information, e to the minus j, actually here I'm going to take the minus out, e to the j pi over 2, and now e to the 3t minus, or e to the j3t times e to the minus j4t is just going to leave me with e to the minus jt. And then the next expression, I've got my phase information, which is plus e to the j minus pi over 2. And then I have e to the minus j3t, e to the positive j4t. So I'm just left with 4 minus 3 gives me e to the jt. And then the last part, I've got my phase is plus e, let me figure this out. So I've got plus e to the minus j, what is this? E to the, I'm going to let the minus signs cancel out. So I've got e to the j pi over 2, e to the j pi over 2 times e to the minus 7jt, e to the minus j 7t. And that's pretty much it. The one last thing I can kind of do that maybe makes it a little bit more clear to see exactly what's going on here is I can write this like this. 1/4 e to the minus j pi over 2 e to the j 7t plus 1/4 e, close that paren there, e to the j pi over 2 e to the minus j 7t, that's the 1/4 there, add on to that plus 1/4 e to the, let's write first this term, e to the j minus pi over 2 e to the jt plus 1/4 e to the j positive pi over 2 e to the minus jt. So now you might wonder why I wrote it like this, and hopefully you can see that I wrote it like this because I very clearly have got two different cosines here represented, right? I've got my phase information, my A is right here for my first cosine, and my A is right here for my second cosine. So anyway, hopefully you found this a little bit useful, or hopefully you found a little bit of the insight here that I took a cosine and a sine and multiplied them together. I multiplied them here, and then I did a whole bunch of complex algebra, and I figured out that really what I could represent this as was adding together two cosines, but the cosines had different frequencies. I can see my omega in each of these expressions. The omega in the second expression is just equal to 1. And even if I wanted to go a step further, here I can even write down exactly what these cosines would be. This is k over 2, or this is equal to 1/2 k is a quarter, so I know that this is 1/2 cosine 7t minus pi over 2, because that's my omega. This is my phase. My phase here is minus pi over 2, plus this k is also 1/2. Choose a different color. Plus 1/2 cosine. Again, my omega is just 1, so cosine t minus pi over 2 is my phase, minus pi over 2. So anyway, you didn't have to do this. Really what you were getting, the answer here you were looking for was this. This is the answer. You've represented that product as a sum of complex exponentials. I just thought it was interesting to go one step further and show that you took two sinusoids, multiplied them together, and through doing a bunch of complex algebra, I could figure out what that would be if instead of multiplying two cosines, I added two cosines with different frequencies. So anyway, hopefully you found that useful. I guess I'll see you in a future video. Thanks for watching.